But section 5, geometric series. We know that geometric in terms of sequences means you multiply by the same thing each time. And from section 4, we know that a series is you take the terms of a sequence and you add them all together. So geometric series. We're going to add up the terms of a geometric sequence, and again we have a special formula for that. Sn is a1 times 1 minus r to the n all over 1 minus r. So where does that formula come from? We're not going to worry about that. That's the formula. Okay? We're not going to worry today about why that is. But what we are going to look at is if we take this formula, the sum of the first n terms is the first term times 1 minus r to the n all over 1 minus r. You could use that, or there's a different form we could use that comes about if we distribute the a1 through on top. We get a1 minus a1 r to the n all over 1 minus r. It depends on what information you're given. Now what happens here is that we know, well, let's look at this algebraically. Using the properties of exponents, a1 times r to the n could be written as a1 r to the n minus 1 times r over 1 minus r. So make sure you're comfortable with that. Right. a1 times r to the n minus 1, that's an. So this is an alternate form of this equation. What's the benefit of having that one? You'll notice here, in this form, if you know the first term and you know the nth term, and you know the common ratio, you can get the sum of the first n terms. Avoiding the problem that we had to deal with on the arithmetic series worksheet, where you didn't know the number of terms. In this formula, take note that you don't need to know how many terms there are. This formula, you do, right? N is the number of terms. This formula, you need to know what the last term is, but you don't need to know how many terms there are. But on the homework for arithmetic series, there were problems where you needed to use the sequence formula to figure out how many terms there were. If you use this formula, you won't have to worry about that. So here, famous story involves a soldier who rescues his king in battle. The king grants him any prize within reason from the riches of the kingdom. Soldier asks for a chessboard with a single kernel of wheat on the first square, 2 kernels of wheat on the second square, then 4, then 8, and so on. For all 64 squares of the chessboard, the king decides the request is reasonable. How many grains of wheat are there going to be? So, this is a geometric series. What is the corresponding geometric sequence? So we have 1, 2, 4, 8, ... Correct? How many terms are there? 64, because they tell us there are 64 squares on the chessboard. So our geometric series, we are summing the first 64 terms, and our formula says that will be the first term times 1 minus r. What is, so minus 2 to the 64th all over 1 minus 2. What does that give us? We get 1.847 times 10 to the 19th. Lots and lots and lots of wheat. Okay? Sorry, it should be 845. This is an infinite geometric series, so we should have seen this before, the symbol for infinity. That, kind of like sideways 8. And again, this is just another formula. The first term divided by 1 minus r. The thing is, we need to know that the sum exists, and the sum for an infinite geometric series exists if and only if r, the absolute value of r, the common ratio, is between 0 and 1. Okay? And when we say infinite, what is it that's infinite? The number of terms. The number of terms goes on forever. But we can only find that sum if the absolute value of r is between 0 and 1. Okay? So here, what is the sum of the geometric series? Part A, the sum, how many terms are there? 7. That is the first term times 1 minus the common ratio to the n all over 1 minus r. We are plugging into the formula. So 1 minus 3 to the 7th times 4 divided by negative 2 gives me 4,372. Part B, how many terms are we dealing with? 12. You have to remember it's top number minus bottom number, so 11 minus 0, 11 minus 0 plus 1. So there are 12 terms. What is the first term? The first term is when n equals 0, the bottom number. 3 times negative 1.5 to the 0, which is 3. Because anything to the 0 power is 1. And 3 times 1 is 3. So this sum is 3 times 1. What is my common ratio? This is the explicit definition for a geometric sequence, telling us that our common ratio is negative 1.5. We raise that to the 12th, all over 1 minus negative 1.5. Notice that I am not multiplying this negative by this negative and making it addition, because that would go against the order of operations. I have negative 1.5 raised to the 12th. I must raise it to this exponent before I do anything with this operation. I have to raise this negative number to the 12th first. So the first term is when n equals 0, which is 3 times negative 1.5 to the 0, which is 3. And then up here, you put this in the calculator. What do we get? Negative 154.496. Game show is offering a prize of 1 penny on the first day, 3 on the second, 9 on the third, etc. What is the total amount of money earned from this prize in 2 weeks? So how many terms are we dealing with? 14. What is the first term?
1.
And since we're dealing with money, we can say this, right? Yeah. We could say 1, but then at the end you'd have to convert, saying that's a certain number of pennies. I'll just convert now. What is the common ratio? 3. So what is the sum of this geometric series? When you do this, it is the first term times 1 minus r to the 14th all over 1 minus r. When you plug that in, you should get $23,914.84. First thing, let's go through. A, B, C. Do they converge or diverge? Converge meaning is the common ratio between, is the absolute value between 0 and 1. Diverge would mean anything else. So in the first one, what is the common ratio? 1/2. So it converges. Part B, what is the common ratio? -3/2. Is that converge or diverge? Diverge. Part C, what is the common ratio? 0.8. So it converges. So for which of these three options can we evaluate the infinite sum? A and B.
C.
Or and C. And then in part B, if you get a homework problem like that, where I just, instead of saying, does it converge or diverge, if I just said, what is the infinite sum, you would just say, there is no infinite sum for part B. Then in parts A and C, we just get to use our formula. The infinite sum, so the sum of the first infinite number of terms, is the first term over 1 minus r. Which is what? -10. Okay, -5 divided by 1/2. We should all know that 1 minus 1/2 is 1/2. And -5 divided by 1/2 is just the same thing as -5 times 2. So we get that sum is -10. What about part C? The sum of the first infinite terms. What is the first term of that infinite geometric series? So this is 1 over 1 minus 0.8. What does that become? I believe 5. From the previous worksheet, we have sum as I goes from 1 to n of -2i minus 2 is -108. This is the question we had at the beginning of class. You are told to determine the number of terms here. You know that the sum of those terms is -108. That's this. And you know that the first term is what you get when you plug in 1 for I, which is -4. So our formula for the sum of the first n terms is n over 2 times the first term plus the nth term, right? We know -108. We know n over 2. We know this is -4. And what is the nth term? All we know is this, right? To solve that, I would start by multiplying both sides by 2. Multiply by 2 to get rid of the fraction, because most of us don't like fractions, right? So get rid of it. So now I have -216 is -2n squared minus 6n. Move everything over to the left. I get this, which is a quadratic. Factor out a 2. I get n squared plus 3n minus 108. That, I would assume, factors nicely. N plus 12, n minus 9. So n is going to be -12, or n is going to be 9. We're talking about the number of terms in a series, so the positive result is the only one that makes sense to us.